Alright, so here's the last part. We got numbers 5 through 10. Number 5, Tom left his home for a run, but he was unfit and gradually came to a stop. So, this is kind of like me running. So, let's see. Let me get a different color. Last one I did was that one. Alright, so we'll go with this color. We've got Tom left has left his home for a run, but he was unfit and gradually came to a stop. That looks like this first one, A, because you can see that this person is making some pretty good distance away from their home in a short amount of time, but then at this line right here, or it's not really a line, but this graph starts kind of leveling off right here, and you see that this person's not making a whole lot of distance away from their house. In fact, it looks like it comes to a complete stop. So the answer number 5 is that one right there. And so now let's do number 6. Tom walked to the store at the end of his street, bought a newspaper, and then ran all the way back. Alright, so what we're looking for is a graph that has kind of a not very steep incline, and then a stop, and then a very steep incline back home. And that looks like it matches this graph right here. Number 6. Let me do a different color. Let's see. Pink. Or pinkish. There we go. So that looks like it goes to this graph, because you see that we have a steady pace, okay, that where this person is walking away from the house, and then stopped right here. I guess this is him buying a newspaper, and then he ran back to his house. So we've got a steady pace heading back to his house, and it's more steep. This slope right here is more steep, so that indicates that his rate of change is faster. So we got walking, stopping, and running back home. Alright, number 7. Number 7 says, Tom went out for a walk with some friends. He suddenly realized he had left his wallet behind. He ran home to get it, and then had to run to catch up with the others. Alright, so we're looking for something where we've got a steady pace leaving the house, and then coming back to the house, and then a faster rate of change leaving the house again. And we see that down here in this graph. So let me circle that. So that color is kind of similar. Let me get something that's different. So number 7 is going to go with this graph right here. You see he's walking with his friends away from his house, and he's like, oh no, I left my wallet. And then he walks back to his house. Okay, so distance from his house goes down to 0, and then he's trying to catch up, so he starts running to catch up with his friends. And you see that's why it's so steep right here. It's because his rate of change has increased. Alright, number 8. The graph is just plain wrong. How can Tom be in 2 places at once? Oh good. I can tell you that this graph right here is the one that is just plain wrong, and I'm going to show it to you, explain why that is. So let's draw this line right here. That graph is just plain wrong, and the reason why is because let's pretend right here at this point right here we'll say that we'll just pretend that says 30 minutes. Like 30 minutes has passed by. Well, this says that he's right here, which we could, you can make up some number. Like you can say that he's 60 feet from his house. But look, at 30 minutes, it says he's also this far from his house. Well, you could say that's like 70 feet. Okay? So, at 30 minutes, he's both here and he's both there. He's at both locations. He's at 60 feet from his house and 70 feet from his house. And at the 30-minute mark. So that is impossible. You can't be at 2 places at once. Okay, at one point in time, you're only at one location. So that's number 8. Number 9. After the party, Tom walked slowly all the way back, all the way home. So after the party, he walked all the way back home. So I'm guessing the party is not at his house because it's saying he's walking home from the party. So we're looking for a graph that is going to start off with him not at his house, but he has a steady pace going back home. And that is this graph right here. So you can see that we start off at no time has passed and he's already far away from his house. But as time passes, he is getting closer and closer and closer to his house, a steady pace, until finally his distance from home is nothing. It's 0. That means he's at his house. So that's the graph that goes with number 9. Alright, last one. We've got make up your own story. Okay, so let's see which graph has not been used. I've used that one. I haven't used that one. I've used that one, that one, that one, that one. I've used that one. I've used that one. Alright, so the only one that I haven't used is this one right here. So I have to make up a story that would match up with this graph right here. And of course you would write it out. So if I was going to make up a story with this one, I could say, you could come up with anything. You can say, I was walking to the store, and then I checked my pocket and realized that I must have dropped my wallet somewhere along the way. So I walked back, I retraced my steps back towards my house. Oh, I found my wallet, so then I started walking to the store again. So now, whenever you're doing your work, don't write about you dropping your wallet because it's going to be obvious that you just copied my answer. But you got to have something to where you've got a steady pace leaving your house, and then you've got a steady pace heading back towards your house. But look, I never go completely back to my house, and then I am going away from my house again. So something has happened here, that caused you to kind of backtrack a little bit towards your house, and then you left to go back to wherever you were going, away from your house. So that's it. That's the last part.